Yes, we are on live.
Good afternoon, everyone. I'm Himedra from the Office of Principal Scientific Advisor to the Government of India. On behalf of the Office of PSA, our organizing partners, FICCI Pune Knowledge Cluster, and IIT Madras Alumni Association, I welcome you to the 11th session of the Innovation and Science at Bharat series. The series has, over the past 10 months, brought in experts who share their experiences of building and nurturing industry-academia relationships to work towards shared goals. The series is meant to reach out to young entrepreneurs, researchers, and research managers working to develop and maintain these relationships. You can watch all of these sessions live on our YouTube channel, Science, Technology, and Innovation in India. The attendees can type in their questions in the YouTube chat box. Continuing with the flavor of this segment of the series, today we listen to experts on adoption of drones in agriculture. From optimizing the use of seed, fertilizers, water, to enabling a quick response against threats posed by weeds and pests, to estimating yield, the applications of drones in agriculture are diverse. In the next few presentations, we deep dive into the work some teams are doing on these lines from across the country. So we first have Professor Himedra Arya from IIT Bombay. Professor Arya is an associate professor at the Institute's Department of Aerospace Engineering. He obtained his BE in Mechanical Engineering from Jodhpur University and later obtained an MTech and PhD at IIT Bombay. His main research interests are hardware in loop simulation, UAV design, UAV system development, swarming algorithm and implementation, and systems engineering. He recently started working towards the applications of drones in agriculture domain, and now I invite him to talk about that. Over to you, Professor.
Thank you, Dr. Seeley. I'll just share my screen.
Yes, please.
Is my screen visible?
Yes, your presentation is visible. You can take presentation mode and start.
Yeah. Thank you, and good afternoon to all of you, all the participants, at least who are within India, good afternoon, and who are in their respective countries, could be good evening or good morning. So, as Dr. Seeley mentioned, I'm Himedra Arya from Department of Aerospace Engineering, IIT Bombay, and I have been working in the domain of drones for the last 15 years, but recently I started looking at agriculture, and it's especially how to use drones in agriculture and what kind of limitations we may face, because the drones also have some limited capability. So my presentation today, I'm going to just give you a very brief idea about what do we mean by drones, and some use cases in agriculture sector, and some challenges, how the academics will participate in addressing those challenges. So this is a brief outline about my presentation. Okay. So if you just hold on. If you try to look at a drone, then I see drone as an enabler. And what do we mean by enabler? It means it's just a tool actually, and its capability gets enhanced by what we attach to this tool. Like the example given here are, if you look at a surveillance, and if you attach a camera to drone, then it becomes, its utility in surveillance is very high. But independently, drone does not have any utility for surveillance. The utility only becomes when camera is attached. Similarly, like we are talking about big way, the last mile delivery is going to come, and it's a speculation is there. Soon we are going to get our food delivery, including pizzas and all those using drones. So in that scenario, if you look at it, what we need is hold and release mechanisms. So that is another attachment which has gone to the tool to make it more useful for that purpose. Now, similarly, when we look at the agriculture, though I have given only two ideas, liquid and liquid dispenser, which is related, could be our pesticide or fertilizer. People are all talking about dispensing seeds. So these are one. Or you can use where special cameras, you can mount it on agriculture, scan it, get images, process it, and then do your AI ML thing. Okay. Let's look at what kind of drones we have. So the first is conventional one, which is a fixed wing, which the picture one, which is given as a flying wing on the right hand side. And the biggest advantage with the fixed wing is it's a high endurance vehicle. When I say high endurance, with the same energy, if you had taken a, let's say some battery and you would have fixed on a fixed wing or multi-copter hybrid, then the fixed wing would have given a very high endurance. But it has a limitation when we are looking at a operational point of view. We need some free space to take off and land. Like the conventional aircraft, they have a runway, but it may not need a runway, but at least you'll need a free space. When you look at the multicopter, these are very compact, have vertical takeoff landing, but these are high energy consuming systems. So the endurance is not as high as what we would have got it in fixed wing. Of course, in the fixed wing, when you look at it, L by D ratio, which governs the endurance. And now we also have a combination of fixed wing plus multicopter, which is hybrid. Now the fixed wing also have a utility, multicopters also have a utility in the agriculture. So I'm not going to get too much into that, but I'm just telling you both have utility in the agriculture. Now, the first thing which comes to mind, why multicopters have become so popular in agriculture. So if you look at the picture on the right hand side, some sketch of multicopter is given. And here, if you look at the construction wise, it's very simple. Few rods connected and then motor propeller and it starts flying. Now, when you look at the fixed wing construction, then you have to actually understand a bit of aerodynamics, bit of controls to actually use it. But in case of multicopter, all that has got very, very simplified. So it's a mainly ease of construction, ease of use, and then compact size. And it's also not very expensive. Remember, this expensive is a very relative term. So let us look at the drones in agriculture. So we know, as I mentioned earlier, that we can mount a camera on the drones and we can have a multispectral camera which can be mounted a drone on a fixed wing or on a multicopter. We can scan the given agriculture area, and once these images are captured, then it can be loaded on a cloud and do your AI ML methods for analysis. But the key issue here is we need large data for training. And I'll also give you some idea a little later. When you look at our agriculture diversity within our country, it's quite large. So actually we need to collect all that data and get it training done for India specific crops. So this is one of the challenge what we have when we look at drones and agriculture. The second challenge what we look at it, when you look at the various crops, what we can have is we can have cereals, vegetables, fruits, etc. When you look at a cereal like paddy, wheat, then this crop is a flat from surface. When you look at the top side, it looks like a very flat crop, which is easier to handle. But when you look at vegetable, the pictures which are shown on the right hand side, which could be sparsely grown in the field for various reasons. So it means now if you want to apply any algorithm, then you have to worry about this part. Because when you're looking at especially about pesticide application, you're looking at application of pesticide on the crop, not on the ground, because you're trying to, using drones, you're trying to save cost on the pesticide application and its harmful effect, which is getting into the soil. So then you need a special way to target only that particular lane where the vegetables are grown. Fruits have another challenge. Fruits have their own canopy. So you cannot use the other algorithm what you have developed for your paddy or wheat, but here you have to use some algorithm which can go and cover the canopy and apply whatever your pesticide you want to it. And now you cannot apply it downward. It has to be applied sideways. That again another challenge. Now, when you look at the Indian scenario, our Indian farmers, they have a farm average, or the large farmers, they have around 2 to 4 acre of land. So field size is small compared to the when you compare US or other countries. So our problems are different than when you look at those US and European countries. And moreover, the field area may be irregular. Okay. And another part is when you look at the farm boundaries, very thin farm boundary, like picture which is given here, which is just a kind of fence which is covered. And in the same farm, the farmer may be growing multiple crops. So what is the challenge from the agriculture point of view? First of all, you have an irregular shape to cover, so the area coverage problem. If you have multiple crops, the pesticide what you're using may not be applicable for different crops. So you have to choose appropriately and apply accordingly. When you're looking at very like the boundary what is shown here, then again at the edge, how do you cover the area? So the area coverage becomes a challenge here. Now, when we look at the expectations from the farmers, what are the expectations? The farmers is looking for a very precise information and the language they understand. The farmer don't want in numbers. They want good, bad, when to apply, how much to apply, these kind of things it requires. Okay. And you can imagine the small farmers, their income is not very large actually. So a small loss can have a very serious implications in their life. So it has to be information what we give, it should be very precise so that farmer and the drone companies can have a trust, and based on the trust, then it will become much easier to use it. Today, farmers are fearful that if you go and try to use it, will it work, not work? Will it give me better crop? Because you're applying less pesticide. The first thing comes is if you're using less pesticide, how can it kill the pests? So that part we have to, it requires little time, but that gap has to be bridged. Then it has the operation, whole operation should be low cost. It means drone has to be affordable for small farmers and they pay only for services. And as I already mentioned, farmers should believe that less pesticide and less fertilizer will give same or better yield. And the services should be available on demand with a very short notice, like a day or two. Because if there's a delay, then it can create a panic because the farmer may feel that after 2 days, if they're not available, what to do. Another important point, the solution what you propose should attract the local youth. So you have to create a solution which makes technology simple to use and can be used by without much of the training. And of course, which increases margin, like reducing operating cost and increase yield. So this is a very brief from my side. And this is just a recap of what academics can do. As I said, agrodiversity. So we need a large number of data set to train for AML. Farm size is small, so we need affordable precision navigation. Similarly, we can look at payload delivery vehicles, which can be of 50 to 100 kg. Like if you look at the farmers who are in the northern region, I mean, I'm talking northern region is if Himalaya or Kashmir, there are a lot of mountain valleys and all that. To even to cover 10-kilometer distance by, which is by air, the road route is around 50 kilometers. So it's become very, very important if such transportation systems are developed. Propeller downwards plays a very important role, but the wind can also play a spoiling part in this. So how to account for the winds in this? And our farms, they have trees, electric supply poles, so how to navigate and have a complete coverage and avoiding obstacles. Maybe possibly we can use drones for repelling birds. Another important point is crowdsourcing. Crowdsourcing is like if some data where some pest and disease can be detected, then it should be quickly shared with the other farmers. And then there could be preventive actions. So these can be some contributions where actually academics is already contributing in this, and we can contribute more in this direction. So these are my contact details, and with this I'll stop.
Thank you, Dr. Arya. That was a very crisp and useful presentation. Thank you for touching upon the challenges of deploying drones in the field, and that brief account that you gave will be very useful for the researchers watching this session. We next have Abhishek Badman from General Aeronautics Private Limited. Abhishek comes with over 20 years of experience working in the aeronautical domain. With a background in aerodynamics, he worked on multiple defense and commercial aircraft projects with various organizations such as ADA and NAL. Today, he will talk about how General Aeronautics is contributing to sustainable agricultural practices through deep research and cutting-edge aeronautical engineering. Over to you, Abhishek.
Abhishek, you're mute.
Abhishek? Abhishek, you need to unmute yourself.
Extremely sorry. Hope you are able to hear me now.
Yes.
Yeah. Yes. Thanks. So, I'll take it forward from where Professor Arya gave us a good brief on what drones could do in agriculture. And in my talk, I am going to talk about two different use cases in agriculture, what we are doing at GA, starting with the problem what we have today in agriculture, and getting little deep into it. I know time is limited, so let me quickly start on that. So the first problem what we are trying to work on is how to have the best pest and disease control in agriculture, which today amounts to about more than, in fact, 15% yield loss every year. And if you see the primary factor, what causes this yield loss is the present process we follow using manual knapsack sprayer. In general, the bioefficacy of such application, bioefficacy in this context is primarily the input you apply vis-a-vis what output you achieve is termed as bioefficacy here. So the primary reason is poor bioefficacy of manual application, which is often pretty non-uniform and inconsistent. And that leads to more overuse of agrochemical. So what Professor Arya was mentioning, less use of agrochemical. Actually, it's not less use of agrochemical. It is, I would say, the right amount of agrochemical use, because we don't reduce the quantity of agrochemical. What we avoid is overuse of agrochemical. So just to give an example, if you have typically there is a recommended number of days within which you need to have the subsequent spray. But if your bioefficacy is not good, if you don't see the application efficiency as good, you end up spraying more and more. What we are trying to avoid is overuse of chemical, because here again it's called active ingredients, which is defined on per acre basis. That remains same, be it drone application or manual application. So that being primary reason, the second reason is with the speed of the application. Manual application often, it's pretty slow. When I say slow, what I mean here, say if you take an example of say paddy crop, which is typically flood irrigated, there you would not get more than 1 to 2 acres in a day by a manual level. So so what it leads to eventually, that if there is a disease outbreak, the containment of disease also becomes a problem. So that's one problem. The third problem, which leads to this kind of inefficiency, is also to do with the maximum residue control. And that is more of, say, I would put it under healthy food category. So if your application is non-uniform And if the pesticide is getting absorbed through the soil, which is to the plant, it often leads to MRL, that is the maximum residue limit, which is recommended for the food, any food we consume, and that often gets violated. And typically, you will see generally the crops which are exported, often they get rejected because of MRLs not being made. So that's one reason of why it adds to this. But I would say the other effect of this kind of application is also to do with, or rather inefficiency which comes into the picture, is also the impact of spray on the human who's doing the job of operator there. Because although there are guidelines in terms of kind of PPE one should use, but on the field, if you see, hardly anybody uses any kind of PPE, and that leads to inhalation of all this toxic fumes and chemicals, and which leads to often number of deaths every year. So this is the primary problem, what we looked at, and we started looking at how to solve this. And if you see the impact side, it has an environmental impact, as Professor was mentioning, that if it goes to soil which doesn't require pesticide, it is only reducing the fertility of the soil. So it is actually a harmful impact one way. MRLs cause food quality deteriorates. Operator availability is a big challenge when you talk about this kind of scenario when there is a disease outbreak and you don't get people to do this spray which is needed. And finally, all this contributes to final income of the farmer, who is now is spending more on input cost, on the labor, and his yield comes down. So overall, at the end of it, farmer whose income is coming down. So to solve this problem, what we not moving. So the first, this was the first prototype we made, which is certified by DGCA. And this system, unlike, as I said, 2 acres a day in a paddy crop, here you can cover. So, it gives you water usage. You typically use 200 liters per acre. Here we are talking about 6 to 8 liters per acre. And the way the spray system is optimized, the bioefficacies are much higher. So it is like, I would say 7 to 8 times better than what you get otherwise in a normal operation. It doesn't lead to any MRL issues because of the uniformity of the application. And eventually the cost of operation comes down significantly to the farmer, and he can make more money out of it. Now, this system, apart from agriculture, we tested it for locust last year when we had a huge locust attack in the country. We participated in that. We had also used it for hotspot disinfection and along with multiple agro use cases. So, as again, Professor was mentioning, that to convince a farmer that this technology will help him to improve the yield or reduce his input cost, it's like there are challenges, as I mentioned. One is bioefficacy and MRL. But other part, as I said, the water dilution comes down from 200 liters to 6 to 8 liters, whereas the amount of agrochemical remains the same. So what it means is you are using much high, or the concentration of liquid what you spray is much higher. And that is one fear which usually researchers or farmers have, that will it cause harm to the crop? Will it burn the crop? And that's called phytotoxicity. So even if you see the new guidelines which has come from Ministry of Agriculture, that demands that even for agrochemical which are approved, you need to do a phytotoxicity test to prove that this can be used using a drone. So we have done plenty of research, not only with various private organization, agrochemical companies and agro producer companies. We have done with 15 different research institutes in 13 states in India. This was a large pilot conducted also to generate data for CIBRC and to prove that technology works in the be it bioefficacy, be it in the terms of MRL, the residue, how it is controlling, and whether it causes any phytotoxicity, which would decide the quantum of liquid which can be sprayed. And based on all this, this is the commercial version. Now we have what we sell now. And this in fact, it has a, I would say, best in class, not only in India, anywhere in the world, type of specification. You can, in a single charge of battery, you can do about 6 acres coverage. And with a less than 1 minute turnaround, you can have very precise droplet control. So you can control droplets between say 70 to 350 microns. What it really means is for different type of agrochemical, which requires different type of droplet size to have best efficiency, you need not really change the nozzle. You can just preset the nozzle, and it has a variable rate technology. So during the fly, it can change the droplet size. It can change also the flow rate, which is something which is required towards precision agriculture. And many other features, which anyway, I hope you are able to see. In case you have any question, because for want of the time, I'll proceed further. And by the way, this solution, what we provide, it's not only the drone, but it goes with a software which helps the entire operation, be it the regulatory aspect, monitoring the drone in real time, or scheduling the operation, planning the mission. Everything is done through GA Hub. And this it's just a simple mobile-based, which is based on Android application. So it is very easy to use UI, and the tagline we say is anyone can fly. So a 10th pass guy, which is the minimum requirement from DGCA, should be able to fly this drone without any difficulty. A lot of research in terms of the type of droplet characteristics which is usable. So here what you see, at the center is the spray characteristics of our drone. And we also evaluated some of the hydraulic drones, hydraulic nozzles, which are used in industry. And on the left, what you see is the kind of coverage you get there. And on the right, what you see right top is the manual spray single pass, and right bottom is 7 passes. So, the spray, what we can get out of GA drone is far superior to manual spray. And I would say even 7 passes of manual spray. A lot of, this is an example of mustard leaf, wherein you can see in a single leaf of say 2 by 4 inches, you have more than 100 droplets. And the best part is even underside of the leaf gets covered with same consistency and uniformity. Same for chili crop. This is, unlike 200 liters, it is with 6 liters per acre dosage. And you can see not even a single leaf which is not covered. And look at the underside, each and every leaf, stem, everything gets covered with the pesticide. So that's the kind of spray technology what we use. And this is what gives us much higher bioefficacy. Just to give you a number, if you go by 2019 data of Niti Aayog, there they had indicated pesticide efficiency in India is less than 1% on an average, right? And here we are talking about in excess of 80%, 80. So that's the kind of comparison. This is, again, a measure of bioefficacy in terms of pest count per plant. This was done by some of the research institute for various crops and various pests. So the way you have to see this plot is if one is the manual operation, number of pests per plant, this is normalized data. What is it for drone? So say if you take whitefly, if drone is manual is 1 pest per crop post application, what you get with drone is around 0.2, which is at least 5 times better than what drone can achieve. Multiple use cases. This is one where we get one complete season with drone, and same similar size was operated manual operation, and we found yield was more than, it was about 35% higher for the entire season. This was for marigold flower. Similar thing for cumin, where the issue is more of residual control, and here it was did this trial where we found the residues of pesticide on the final produce. It was measured and found to be less than 10% of the specified limit. We did a lot of other trial with various ICAR labs. This was with CPRI, And this is with Punjab Agriculture University on aerial bioefficacy and phytotoxicity evaluation. This was with NRRI, CPCRI. So on the summary, if you see, these are the key parameters. Bioefficacy, drone application is far better. Residue control also is superior to manual application. Phytotoxicity, absolutely no issue, and that can be controlled pretty well. In terms of operator safety, far, far better. Of course, drift drone would be generally higher than what you can achieve with manual, but this can be controlled by various means. The time saving is significant and water usage comes down significantly. And the cost of operation today it can be brought to at par with what farmers are paying for manual spray. So that was the first use case of blanket spraying. And now quickly I'll take you through precision agriculture, wherein first we do a survey. And then that data is used to train the AI model, and then AI model is used to detect where the problems are. And today we could get about 92% accuracy for coconut plantation. And then eventually you get a report where you get the plant ID and lat long of the plant and whether it is defected or normal. And this information then goes to the spray system. And imagine this is the field where the dots are the defective plant. Then the sprayer drone automatically plans a mission in a manner that in the minimum time it can cover the entire field and spray only where it is needed, depending on the coverage what drone has from a particular point. So that's it. Thank you very much for your kind attention. If you have any question, thank you.
Thank you, Abhishek. We'll take all the questions after the 4 presentations are done.
Sure. Sure. Thanks.
At this point, I would like to inform our attendees on YouTube that they can visit this events page on our website to download presentations from all the previous sessions, and the presentations for this session will be available to you in a day or two. Our next speaker for today is Somnath Das Gupta from Prime UAV. Somnath has got 23 years of corporate experiences in senior management roles. He is with Prime UAV now, and today he will be talking about the work being done by his organization and briefly reflect on the partnerships that the organization has developed with academia. Some of the agricultural services provided by Prime include monitoring crop health pre-harvest, assessment of crop damage, detection of leakage in irrigation systems for effective use of water resources. And I think I'll let Somnath talk more about what Prime
Can you
UAV.
see my slide? Thank you very much, ma'am.
We can see your slides, Somnath.
Okay, thank you very much. So I'd like to thank Dr. Arya for the enlightening presentation. And before that, I'd like to thank Dr. Mitra on behalf of the Office of the Principal Scientific Advisor, Mr. Manish. And I would also like to thank Mr. Badman for the eye-opening presentation. We are Prime UAV and our focus is on agriculture drone applications. And we would briefly cover 6 points on the various aspects covering our journey and our applications. So we established ourselves in 2019 with a prime objective of working in a very focused manner in agriculture, and that has been possible because of our R&D mindset, because we understand that it is only through R&D that disruptive models and innovation which can improve the quality of lives can be found. And we have a very humble beginning, but it's better than a garage. So our mission is, as I said, to develop innovative solutions for agriculture, and our vision has been to deliver smart agricultural practices which improves not just the productivity for the farmer, but also reduces the input cost and the other collateral, the hazards and the risks that are associated with this particular vast field. And as we all know that 58% of India's population is actually dependent on agriculture. So these are some of the applications that we've been very actively working upon, primarily based on spectral imagery, primarily based on infrared imagery, and our lab-based product, which is the sprayer drones. And so we have been working on crop monitoring and nutrition and pesticides spraying, plant emergence and population. These are some of the areas that we've already covered during our beta pilots, crop protection and insurance. We've also been able to work very interestingly, we've been able to also work on harvest planning, which is a very important feature because of the vagaries of the monsoon. The farmers are absolutely uncertain about what are the output that can be there and what kind of water availability and irrigability will be there. So other than that, soil assessment, crop counting and yield potential, along with leak detection, which is a very important facet because we've always observed that uh, where there was a very important parameter of a particular water level because of certain flaws, certain leakages, the water table and the water receded owing to the loss in crop and pest detection. So all this has been possible because of the extensive use and understanding of our systems of spectral imagery and infrared as well as aerial imagery. A very interesting application that we co-developed with ISM is basically seed spreading, where this was a very specifically developed drone, where this drone could disperse, radially seeds in areas where it is very difficult for a farmer to accurately go and spread the seeds because of the knee-deep water. So this is actually a game changer, and we have already conducted beta testings on it, and the beta testings have been extremely successful. We would like to also highlight the critical pain points in agricultural sector, both in terms of manual spraying as well as equipment spraying through equipments like tractor, etc. And some of the major problems that we all have been able to identify in manual spraying is not just the danger or the hazard for the farmer himself in terms of various kinds of disease, etc. But another very important problem is that there is a very imminent lack of labor, very imminent lack of the current generation who wants to work, stay back in a village and work on agriculture. So as we see that there is a mass exodus from the villages to the urban conglomerate. So these are some of the very important problems, not just that. Another is difficulty in understanding the volume and the time of the arrival of the monsoon because our agriculture is still very, very dependent on the vagaries of the monsoon. And as far as the equipment spraying is concerned, as we all know that after the Green Revolution, things changed. But as we have learned over these years that spraying or conducting agricultural activity through these tractors or special equipments also has its own pros and cons. It requires a huge amount of space, and there is also, pesticide wastage. And as we can all appreciate that it is difficult for a tractor to spray evenly or even approach a hilly or a slopey terrain. So we came out and with this aerial sprayer drone, and we've tested it extensively. And some of the benefits of the automatic sprayer drone is that, as we said earlier, that the basic issue of farmer safety, as we all know, that the collateral damage can extend up to cancer and heart attack and danger of poisonous animals which are there. And spraying on uneven surfaces like, the hilly terrains, etc. Another very important thing which is directly related to the income levels of these small farmers is basically the pesticide saving, which means savings in money. And naturally, it boils down to increase in production. And as we all know, that spraying is 50 times faster than the manual process and 10 times faster than the equipment spraying techniques. Another very important thing which has an ecological connotation is basically the saving of the groundwater levels or the water table levels, because the programmable softwares can actually ensure that there is optimization of spray and optimization of water mixed with it. And another very important thing is basically in terms of environmental pollution is the collateral suspended aerosol contamination in the immediate habitable vicinity because of the wind drift, etc. And so that our drone, we have been able to design the drone in such a way, design the speed and the PSI and the nozzle in such a way so that the drift is absolutely less, and ultimately it results in a huge saving in cost. And all this is possible with a simple handheld device. So like Professor Arya was talking about a more involvement of the village youth in something which is smart, something which is easily operatable. So I think these kind of technologies can actually, arrest the flow of youth from the villages to the urban setups. And basically, before carrying out the land fencing or the geofencing by various, GPS, etc., can actually ensure that we are not, over crossing the targeted area of productivity than that is required. Now, we've tested this on a wide range of fruits and vegetables, like which is here, right from sugarcane to chili to paddy to soybeans, grams, etc., etc. And some of the case studies where we've been able to remove the red dots while spraying, and we've been able to study very extensively are on grapes and on sugarcane. Our current products are basically the 10-liter and the 16-liter and the 24-liter drones, which have variable speeds and variable nozzle control parameters. And we have been able to also develop very user-friendly software whereby, a person, let's say in Gujarat, can use it in Gujarati. So things like that. So we've been also be able to customize it to that particular extent. Some of the machine details are this, return to home functions. Our current drone products are basically the 16-liter folded, which is very useful in carrying it from one area to the other area in a simple car also. 16-liter unfolded, 10-liter hexa, 10-liter quad, and a 10-liter folded drone. So one of our very important milestone project was on the locust control that happened between December 27th, 2019 to 18th May 2020, where we worked extensively with SDAU to understand the entomological behavior of this locust. And as you know, that this was a huge risk and a huge hazard to all the farmers and their livelihoods. And this resulted in huge ground level success. Nearly 360 villages were covered, and over a radial area of 28,387 square kilometers. And at the end of the day, we saw that we were able to put a reassuring smile back on the, on the villagers and the farmers. So these are some of the images. The one that you see on the left-hand side would give you an idea of the teeming locust strength, which was brought down. Images of our team on the field. And these these sprays had to be started early in the morning, right at 5 a.m. sharp, and it had to be done till 8 a.m. So another very important facet of this particular presentation is the need for the academia-industry linkage. So in our opinion, it is very important for the germination and incubation of this particular linkage is that we are able to therefore give birth to innovation and disruption that can better our lives. And this model is followed extensively in European countries. Just to give you a small example, that the USA has long instituted something called a triple helix model, where the university, the industry, and the government all participate together. And there in 1980, something called the BAYH Dole Act was actually constituted or instituted to help, patents churning out of this industry. And for example, in Germany, you would be interested to know that almost 400,000 universities are actually participating with the industry in these kind of academic linkages. Whereas in China, there is the Scientific and Technology Progress Law, where almost 22,000 regular colleges are involved with this. So, like I said, some of these iconic brands like General Electric and Siemens are basically products of this, and they still work with the universities. And we feel that one of the easiest ways of realizing this $3 trillion economic goal is a sure short way is to foster a relationship with the university. And in our opinion, we have some suggestions. We feel that if there is an easy access to the knowledge and the mentor pool in universities, it will be very beneficial. And there should also be a very easy process to validate the techno-commercial viability by the universities and thus understanding the market opportunity. There should also be easier access to funding programs for those eligible. And maybe the Office of the Principal Scientific Advisor can contemplate upon instituting a monthly calendar of competition and invitations with these various universities at the national level and state levels, whereby various companies from various states, etc., can participate. And the last but most important point is that we need an integrated platform, a single window, where the Department of MSME, Science and Technology, Promotion of Industry and Internal Trade, which deals with patents and copyrights, are there working together so that the process ultimately shortens, the time shortens, and ultimately all can benefit. Some of the associations that we've had with various industries, which have been extremely valuable, are with Anand, where we've tested on this agricultural spraying system, with Navsari Agricultural University, where, as you can see, we've conducted various seminars and demonstrations, helped students. As we mentioned earlier, with SDAU.
Somnath,
Yes.
we will have to be a little mindful for the time right now. We
Yes,
have
ma'am. I'm just here. So
Thank
Nirma and Ganpat University, and these are some of the images, some of the products, and I'd like to thank you. Sorry for overshooting the time, ma'am. Thank you very much.
Thank you. Thank you so much, Somnath. About the last 2 points of your academia industry linkages slide, so you will find some relevant information on our website. You'll need to look at the web page for the Division of Strategic Alliances, which builds up the industry and academia relationships. They have several calls for such competitions where industry partners and academia partners participate. So you'll find some information.
Okay, ma'am. Thank you.
So coming to the last presentation for today, we have Shiva Kumar, Chief from Multiplex Drone Private Limited. As Head Technology and Operations at Multiplex Drone, Shiva Kumar monitors a team of UAV design engineers and UAV pilots. The company has developed drones of different payloads used in the agriculture sector. He's monitoring a fleet of 15 agricultural drones and a team of 20 drone pilots for spraying pesticides, fungicides, and growth promoters for over more than 2,000 acres in Karnataka, Goa, Maharashtra, and Pradesh. The company initiated the Indian Institute of Drones for training in the Karnataka region. I invite Shiva Kumar for his presentation where he can talk about more on their training initiatives. Over to you, Shiva. Shiva Kumar, you'll need to unmute yourself.
Is my voice audible now?
आप देखिए
You are audible and we
Yeah.
can see
Hello?
this.
Okay,
Shiva, you can start now.
thank you. Good evening to one and all. I am Shiva Kumar from Multiplex Drone Private Limited. I would like to share my journey of developing agriculture drones and how we were able to execute and do the implementing the technology of drone in agriculture. Basically, our sister company or the group of companies, which was established in 1974 by eminent scientist Dr. G.P. Shetty. He is basically a plant expertise in plant nutrition and plant physiology. And we have a cluster of companies like Karnataka Agrochemicals, Multiplex Biotech, GPS Institute of Agriculture Management. So the group is well versed with the manufacturing of bioorganic manure, micronutrients, biopesticides, and growth promoters. So there was a lot of people who are already in the were already eminent experts in the agricultural inputs. Also, there is another organization called GPS Institute of Agriculture Management, where it's an agricultural education institution. So even there, a lot of staff and students were actively involved with our projects. And Multiplex Drone is basically involved with agriculture drone manufacturing and spray service. So we do also have a laboratory where we can test the soil, the plantations, the leaf, which, and moreover, all these laboratory is an NABL accredited laboratory. And the company has various products like biofertilizers, growth promoter, biopesticides, and additionally, recently we started even an agricultural drone. In Multiplex Drone, the organization which was started in 2019, within the organization we have major 4 departments where we more focus on the development of the product, where the research and development team is there, and we also look even for how to train the employees and the students, because flying a normal drone is different and flying an agriculture drone is different. There are a lot of parameters the pilot needs to keep in mind. And we also have an in-house for drone manufacturing. Currently, we are doing 5-10 liters pesticide spraying drone for the agri input. I need to share how this concept of agriculture drone came into the thought. In year 2018, there was an incident happened. The pesticides when the farmers were trying to spray these pesticides on the cotton, which is around 5 to 6 feet height. So because of the wind drift, the farmers inhaled the pesticides. So this resulted in death of around 18 farmers, and 800 farmers were hospitalized. So this incident ignited our mind and the managing director of our organization that some technology needs to overcome this. Some technology needs to be brought out in avoiding these kind of health hazard operations. So the aerial technology will be the right thing which we initiated for a safe operation. Then when we started the aerial technologies, then we developed the drone. Then later we realized not only the health hazard, but there are other advantages when we implement this drone technology. So we focused more on drone for aerial spraying. In this way, the industry partners like Multiplex Drone and Multiplex Biotech. In Multiplex Drone, we had a set of team with agricultural drone development, and which were actively involved in spray trials, reaching out the fields. In multiplex biotech, we had agronomy experts and doctorates with what is the need of the plant, what is the disease observed in the, what is the right input has to be given to the plant and what dose. And GPS Institute of Agriculture Management is an academic institution which supported in conducting the field trials, because there are a lot of agriculture students, even they need to observe what is the disease or what is deficient in the plant, how it needs to be tackled. So there was a lot of knowledge exchange and as well as uh, interaction between industry and academic institution also. And a few student project and internship was given to Rama University of Applied Science for understanding the drone structural analysis, what kind of metals to be used compared to aluminum, composite metals are better. So, and building the prototype for SJCIT organization. So this way, industry and academia were actively involved in developing the product. So when it comes to the development of a drone platform, we first focused on what is a normal drone and how it needs to be different compared to agricultural input spraying drone. In a normal drone, for example, if in case of a mapping application, there are certain parameters like photo quality, pixel, what height we capture, what is the camera angle. And in videography, it's more of an image resolution, ISO settings, that's few parameters. Whereas we consider in agricultural spraying drone, we need a flight control with a proper, very precise altitude hold so that the height of the input is spread precisely, and the accuracy in the geo mapping the boundaries, because once we map, it should not overlap and even it should not reach out the boundaries of a neighbor farmer. And what is a suitable farming flying speed? The flying speed, it varies from 1 meter to 5 meter per second. So what is a suitable optimized flying speed for the drone, and how much would the water is required per hectare or on an acre basis? What is a suitable payload drone needs to be taken care? How long we need to fly? What is the endurance? Structural stability? What is the swath we need to consider? And the pump should automatically slow down the discharge of the agri inputs when it comes to the corner of the farm. So the spray needs to stop when the drone is crossing because the speed reduces. So these are all the parameters we considered when we were started developing the agriculture. So when it comes to the aerial spray parameters, there were a few aerospace engineers from academics and industry which were actively concentrating. We kept few parameters in mind. What is an optimized swath of spray to be done? What is the speed of the drone? And how much discharge needs to be done? Is it 1 liter per minute, 3 liter per minute, 0.5 liter per minute? So depending on the crop stage, disease level, all those things were considered. And what height we need to spray over the crop. And what is the wind speed? There's a lot of drift happens in wind speed. What is the right atmospheric condition? What about the temperature, humidity? These were all the parameters were studied and observed by the aerospace engineers. When it comes to the agronomist, they handled things like density of the droplets on the leaf, bioefficacy, phytotoxicity, and what is the residual limit in the crops, and what are the different agri inputs. It can be a fungicide, it can be insecticides, the growth promoter. What is the recommended concentration needs to be taken care? What is the right dose per acre? All these things were handled by the agronomist in our team. So, and we used to test in one season at 4 different locations. There were a few things which we tested in our own in-house. We have our own farm with 55 acres. We are used to test there. And also, since Multiplex is having pan-India presence, we are more connected with a lot of farmers. So we requested them to give a test area. For example, there are like 20, 30 acres, big farmer. We requested him to give a 0.5 acre or something. Then we can test it. So at various geological location, various climatic location, how the drone was able to work compared to the manual and conventional spray systems. So this is a few sequence of our testing area, like with various swath and various height. We recorded the droplet distribution on the plants and leaf. So when we were carrying out these kind of test operations, There were a few things which we also kept in mind, that we don't fly over the water bodies, and all the pilots will fly the drones on the visual line of sight and operation only in the daytime. And the challenges was like the present agronomists, the the drone was a new technology. They were surprised like how the technology needs to be implemented. The agronomists were regularly recommending to farmers with the conventional sprayer. It can be an APAC sprayer, it can be power sprayers. So they used to use 200 liter of water, sometimes even 300, sometimes 150 liter of water. But when we recommended that ultra low volume nozzle, it uses less water. Right from the research team as well as farmers were surprised. How can you spray? With present day, we are using 200 liters. How are you able to spray with less amount of water, with 8 to 10 liters? So this was a little challenge and resistance from the farming community to accept the technology. So we used to do a lot of knowledge session and exchange of knowledge, then convince the farmer, and then we were able to give only request for a test plot. So even they were surprised, what is the concentration? What we used to apply for 200 liter, how can you apply for 100 like 10 liter? Doesn't it make scorching? These were the common kind of questions, and they used to use 1.5 2 liter 2 hours to spray some like 1 acre, but we used to do with 8 to 10 minutes. There was a lot of surprise and resistance for new technology. And when it comes to the crops, India has a very diversified crops. In some places we have a field crop. It has like paddy, wheat, and sugarcane. There are in paddy also some crops like tur dal and flowers were well spread uniformly throughout the farm. There are other crops like row crops, tomato which has a stacking, chili, cabbage, for example. And there are other plantation like tall plantations, coconut, areca, and rubber. So in all these things, the uniform distribution of the crop is different, and the height of the canopy is different. So these were a lot of challenges, like how the pilots were having few initial challenges, how we need to handle this kind of a different farm. One is fragmented land is there, and most of the farms are not very the proper square shape. Some places we used to have turning, some places we used to have a power line, some places we used to have a lot of obstacles like tree. So these were the kind of challenges which we faced during the operation. In coming to aerospace team, the challenges were like, what is the drift because of the wind scenario, and will the spray will reach out the neighbor farm. So we used to keep these things in mind: rotor wake, propeller downwash, especially when we fly the drones over the tender flowers of chili, rose, and mango. We used to keep very precaution during these kind of operations, and the aerodynamic study of the droplets and the droplet distribution over uniformly throughout the farm, because the droplet distribution may be more dense in the top canopy of the plant, and slowly it might reduce in the mid part and lower part of the plantation. So these things were challenges when we started implementing the drone technology into the agriculture. So we did a lot of reach out to farmers, we did a lot of demonstration, we did a lot of trials. So these are the few snaps which we have taken. So the outcome was, the drone is a very good technology. It can do a better pest control management and effective agriculture input application. It's one thing. Already the previous speakers have highlighted this. And quick coverage for large areas. For example, if there's a sudden change in the weather, like cyclone, or it's about to rain tomorrow day after, like at the scenario, the farmer needs to cover lot area of farm, so he may find shortage of laborers and skilled laborers. So drone technology could be a right technology which can generate employment generation. So in this way, multiplex drone is very happy in working on this kind of technology, which is a national building technology. And our logo also, we have a multiplex farmer, happy farmer. So we are very keen to work with farmer and ensure the smile is always there on the farmer's face. So these are the few drone which we have built in-house. We have a MD5Q. It's a quadcopter 5-liter payload drone.
Shiva Kumar will need to wind up now. I'm
Yeah.
hoping these are the last few
And
slides of yours.
and we have a 10-liter in-house developed drone. We have covered more than 2,100 acres with 250 farmers and demonstrated almost like 3,000 demonstration, and in almost in the South India, around 25 districts we have covered. And moreover, the 85% of the water has been saved, and 22,000 of agri inputs has been sprayed. We also share our knowledge and give demonstration. We presented our product in Krishi Mela GKVK. We also conduct workshop with colleges. We also conduct webinar to agri input dealers. What this is technology, how you can reach out more farmers. And we also write a lot of articles in Multiplex Wahini magazine, which is reaching out to 50,000 farmers. We also reach out with organizations which agriculture students, so that what we learn, what we have found out in agriculture technology should reach more people and more farmers. In this way, this will support more agriculture community. These are the crops which I have covered till date. Media coverage of our activity. Yeah, I would like to thank the FICCI and the PSA for giving an opportunity to share my ideas and company ideology and the product technology.
Thank you.
Yeah,
Thank you,
thank you.
Kumar. So, in interest of time, I would not take all of the questions that have been posted. There are a few questions. Most of the questions are about the application in agriculture, like pesticides application, controlling weed growth, which have been responded to by the speakers during the presentations. So I'll take one question which is on drone manufacturing in India. I'll make it more specific given the theme of the series. Can you tell us about the R&D challenges that drone manufacturers face and how an academic partnership will help? So basically, could you list out the R&D problems in drone manufacturing, if any of you could take that question? Any of the four speakers, please.
So, Dr. Seeley, you want me to respond?
Please, Dr. Arya.
Yeah, okay. So when you look at the drones, I'm putting in a very broad sense what are the components we have. One is structure, another is autopilot board and sensors, and then we have motor propellers and ESC when you look at broadly. Okay, so there is structure which is made out of composites, which is made out of carbon tubes and plates, which is, I believe it's easier to make it. Okay, the challenge is in making the motors, propellers, which is a big challenge. Till now, we don't have any company within our country which can make those things. Okay, and then autopilot board, again, it's a choice. It's available as open source. You can just take it and use it. So when you look at manufacturing point of view, I would say industry and researchers should target motor and propeller. That's one of the critical technology which is required. So other speakers can also respond to this. These are my view.
Yeah, I would like to few more.
Please.
Yeah, especially when the flight controller, the area may not be uniform, maybe not a proper rectangular shapes or anything. We go for an auto. We need a good algorithm where it can find what is the right crop canopy is there. Where is there any weeds? For example, when we fly over the coconut plantation, so we need to find what is the right canopy of the coconut. In between, there is a lot of open space. So at that time, we need not spray. It can be effectively utilized in applying the agri inputs. So these things, and especially for example in areca plantation, the canopy height is different from one plant to other. There will be almost a variation of 8 to 10 feet from one plant to other. So the canopy height needs to be taken care. So any good obstacle avoidance with 360-degree, with also can implement work with the flight control, will be really great. But these things has to be indigenously developed. That's more important rather than importing from neighboring countries.
Dr. Mitra, I would request my colleague Pradeep Patel, to respond to this particular question.
Sure. Thank you, Pradeep. Please go ahead.
Unmute, Pradeep.
Pradeep, you will need to unmute yourself.
Okay. In the agriculture drone sector and the drone sector, the basically controller and the some electronics part is not available in India. That is the big issue for the drone manufacturing company, because right now drone is the growing industry. So mass production is not possible for the every company. Okay, and due to the mass production, low product output, we are not getting the best cheap price compared to the other countries. So this is the huge challenge for the drone industry. But for the mechanical and the some Professor Hemchandra Arya sir that told that the motor and the propeller company have to come for the manufacturing. But that is now one day by day it's going on. But electronics parts is very difficult for the right now in the drone industry. So someone have to take the bigger company have to take the action for the mass production for the some core component like the electronics circuit and IC like that.
Right. Thank you for taking the question, Pradeep.
Thank you very much.
Dr. Sioli, can I add?
Yes, Abhishek. Please go ahead.
Yeah. So, in addition to what speakers mentioned, I would also like to point out, there is very good potential in terms of improving the battery technology, in terms of getting best out of the cells, because of course cells are not, perhaps it is just getting started in India, but it is not really available and we end up importing. But there is lot lies in the battery management system, which one can optimize to get best out of it. That's number one. And towards making the system autonomous, thereby it is easier for, as professor and other speaker mentioned, even a micro entrepreneur or a 10th pass guy to fly. If we can make the system autonomous, and there, the aspects like sense and avoid and better control of the system plays a major role. Now, those things also depend on the kind of sensors which are available. And if you look at the sensors which are available, the cost becomes very high. And then, finally, because your end user is farmer, where you want to go in a kind of OPEX model and the cost has to be at par with what he's paying otherwise, that becomes a challenging issue. So that's where perhaps, with academia and industry, we can find different ways of handling this, be it in the terms of accuracy or having a better autonomous system. So that's all I want to add. Thank you.
Thank you, Abhishek. I would not be taking the rest of the questions, but I would request our attendees to look at the presentations. This video will be uploaded on our social media accounts as well, and they will, I hope they will get their answers over there. Ending this session, and looking back at the last year, the Office of PSA has brought together industry partners, startups, and academic institutions to develop innovative solutions to support different R&D sectors through the Innovation and Science at Bharat initiative. Through this series, we hope to build and nurture more such partnerships, and we largely depend on our speakers to ensure that happens. So I'm very thankful to all of you and your organizations for participating in today's session. I'm extremely grateful to the teams from FICCI, Pune Knowledge Cluster, and IIT Madras Alumni Association for helping us put together this series. If you missed the session, the recording will be available on our social media accounts and the YouTube, and the video will be there on our website. Do join us as we meet experts to talk about drones in healthcare next month. Thank you everyone for joining. Thank you very much.
Thank you. Thank you, everyone.
Thank you, ma'am.
Thank you, everyone.
Thanks, and be safe and happy time.
Thank you.
Thank you, everyone.
Thanks, Prachi.